Hello dear learners, welcome to this session. This session is second in its series for the course BEY-020, BCS-111 and BCS-011, and the course title is Computer Basics and PC Software. So this session is the second session. Let us recap what we had studied in the first session. In the first session, we had started with the preliminary definition of a computer, its applications, and then we had seen various generations of the computers. So, as a part of the preliminary definition, we had seen there are three types of components involved in a computer while defining. One is the input, second is the process, and third is the output. So this was the simple basic diagram we had studied in the first session. In this session, let us try to move on to the next sections of Unit 1, Block 1 of Computer Basics and PC Software. So in this session, let us see how a computer works, on which particular architecture the present computers are modeled, and then towards the end we will see what is an operating system, what are its goals, objectives, and what are the functions of an operating system. So this is the agenda for our today's discussion. So as you know, a computer is an electronic device that performs operations based on instructions provided by the user. So it will accept the data from the user, processes it as per the instructions provided by the user in the form of a program, and then produces the output either in the form of a printout or else it can be displayed onto the monitor. So computers not only perform the calculations and listen to the instructions, however, they store the data for later use in the storage devices, and then later on we can retrieve the outputs or else the reports whenever they are necessary. So in addition to the calculations part, there is a storage part also, wherein which once again if you want to reuse the kind of data or the reports, you can use them. So these particular computers, as you can see nowadays, there is a wide variety of range available regarding its speed, regarding its size and capability. There are simple computers, those are available in the form of tablets and laptops, and there are large systems like the servers and the supercomputers. So each and every, once again if you take the case of a desktop, it may be a very simple desktop which will be helping you in accommodating the day-to-day activities. However, it may be a desktop which may be catering to a high-end applications also. Likewise, the similar case with the laptop also. It may be used just for some sort of word processing or spreadsheet package processing, or else it may be used to interact with the cloud environment, wherein which you can like ask for the resources and other kinds of things through the web portal that they had launched. So these particular computers play a very essential role in various kinds of domains, including the education, science, industry, entertainment, and personal use, and due to their ability to process vast amounts of information quickly and accurately. So nowadays it became a kind of a routine to use the computers in the form of laptops, in the form of desktops, or even most of the simple processing we are doing it through our mobile phone itself, or else the tab that we are having at our hand. So there are two components wherein which we have to concentrate whenever we define a computer. One particular component is called as the hardware component, and the second thing is called as the software. So both these things constitute a computer. So this particular hardware refers to the physical components of a computer, like the circuitry you see, the monitor you see, so where in which you can see and feel that particular physical part or physical component of the computer, we can mention it as a hardware. Something like the CPU, the memory, the registers, the circuitry, the IC, or is the plastic parts, the plastic coverage, and then memory, storage devices, the RAM, the ROM, the hard disk that it had, and then the input-output devices like the keyboard, mouse, monitor, pen drive, whatnot. All these particular things comes under the hardware part, where in which you can see them, you can feel them, and physically they are existing in the form of a component. So when it comes to the software, it includes operating systems and applications. So within this particular software also, whatever the programs that we write, whatever the instructions that we write, we call it as a program. Sequence of instructions is called as a program. And it includes both, like one particular software component is the system software, and the other component wherein which we interact mostly is the application software. System software, we can differentiate or define it as whatever that supports or cooperates or monitors the system activities is called as the system software. And when it comes to the application software, just like the packages that we use, the word processing packages, spreadsheet packages, or else the web browsing that we do, or else the office suites, or else the games that we play on the computer. So all these things comes under the application software. But when it comes to the system, you have to remember that it supports the systemic operations or systemic monitoring, or else it coordinates with the computer system. Whatever the command that the user is giving, it should understand, and then the computer has to take certain actions. So all these things will be done by the system software, especially by the operating system. So this was the diagram that we were discussing earlier. So it is a simple block diagram wherein which input is given by the user, and then it undergoes certain calculations or then processing, and then wherever there is the part that needs to be retrieved from the storage, those particular inputs that it will take as per the instructions, or else whatever that needs to be stored is being stored into the storage, and then whatever the output that needs to be given in the form of a printout or in the form of a display on the monitor, those will be displayed, and that comes under the output part. But let us see on which particular architecture or else on which particular model the present computers are being modeled. There is one particular scientist with name von Neumann. So he has designed a particular model very earlier days. So on that particular architecture, the complete whatever the systems that we are looking today, whatever the systems that we are using today, the model is dependent upon von Neumann architecture. So von Neumann architecture is a computer design model. So that describes a system where the CPU is present, memory is present, and input-output devices are connected. As you can see, this particular architecture was proposed very early. However, till now, we are using the same kind of model or the architecture even for the computers, tablets, laptops, and even for the mobile phones also. So in this architecture, both the data and the program instructions are stored in the same memory space. The CPU, the central processing unit, fetches instructions from memory, decodes them, and then executes them in a sequential manner. So in this particular architecture, earlier we had seen in the previous session, we had seen several like calculating devices, right from mechanical calculators till the digital calculators. We had seen the complete evolving of the calculating devices. So in that, we haven't seen the kind of concept that the CPU is existing or else the memory is existing. Only in the von Neumann architecture it is been mentioned, and present days also we are totally dependent upon the complete architecture given by the von Neumann. So it has a kind of single bus. Single bus is nothing but a kind of communication channel for transferring the data, meaning only one operation can happen at a time, making it very simpler, and there may be a possibility of slowing down of the multitasking. However, basing upon this particular model, many kinds of multitasking, parallel processing, and other kinds of models have been evolved, as we are saying in the present day. So this design forms the foundation of most modern computers. Charles Babbage has proposed something else, and then later on there are several developments that those have been happened. However, it ended with the proposal of the Van Neumann architecture for the modern computer design. So this is the Van Neumann architecture. As you can see, this is a very simple block diagram, and the other diagram, whatever we had seen earlier, it consists of only the input, process, and then the output. However, in the Van Neumann architecture, you can see the clear-cut definitions for the input, like a device kind of thing is placed in the input, and then there is instead of process, it is being clearly defined that a unit like the central processing unit will be present. Along with that, in order to coordinate, control the complete computer instructions, the control unit is the supervisor, and then arithmetic logic unit is meant for the arithmetic and logic calculations depending upon the operations that are given in the program. So once again, there is a memory unit which has been highlighted over here, wherein which it can take the instructions can take the data from the memory, or else it can throw in or else save the data into the memory. So both that bidirectional arrows are being placed over there in order to fetch in, or else in order to store the data into the memory unit. Once again, there are certain devices which supports the output also. So this is the architecture proposed by Van Neumann, wherein which all the modern computers that we are using today are being modeled. So whenever we discuss the computer, there are certain things which are there we had seen in the Van Neumann architecture. One by one we will discuss the components we will discuss over here. The first component is the central processing unit, the main memory, hard disk, input devices, and then the output devices. The central processing unit is also being referred as the brain of the computer. So this is basically the centralized unit wherein which it is responsible for executing the instructions from programs by performing basic arithmetic, logic, control, and input-output operations. So the complete processing, you can say, the complete processing is being carried out by the central processing unit. So it has certain core components inside, and one component we can call it as the control unit, which is responsible for coordinating all the instructions. Whatever the instructions those are given in the program or given by the user from outside, so all those things needs to be understood, and then it should be well coordinated with the devices. Those are like forming the kind of environment within the computer. So one particular thing is the component is the control unit, which is very much essential part of the CPU, and the second one is the arithmetic logic unit, wherein which the complete arithmetic and logical operations takes place, and then there are immediate very fastest memory kind of elements available called as the registers, and then there is another fast memory which is very much close to the CPU, that is called as the cache memory. One by one we will see. And then coming to the control unit and the arithmetic logic unit, the control unit is the complete supervisor which directs the operation of the processor by telling the system's memory, arithmetic logic unit, and the input output devices how to respond to the instructions. So that is the complete supervisor kind of element or component present in the CPU, which is the responsible component, and it will say how to respond to each and every instruction. Suppose if there is an input instruction, obviously it has to take care, it will direct the thing to take care that the data needs to be fetched in from the memory. Suppose it has to output something onto the monitor, it will be saying that this particular thing needs to be output on the video. So this is the complete kind of a coordination unit wherein which it has to support the understanding of the whole instructions and directions to be given to respond to those particular instructions by various devices present in the computer. Then comes the essential component called as the arithmetic logic unit. So this particular arithmetic logic unit is responsible to perform all the arithmetic addition, subtraction, division, whatnot, all these operations, and also the logical operations. Maybe some sort of comparisons, whether greater than, less than, greater than, equal to, less than, equal to, is equal to. So all these kinds of logical logical and, logical or, logical not. So all these operations will be looked after by the logical arithmetic logic unit. So there are certain elements present in the component CPU which are once again essential in the form that the registers and the cache are present. Registers are nothing but they are very small in nature, and then they have the high speed storage locations within the CPU which will hold the data temporarily for processing, such as operands, intermediate results, and then the addresses from which the data needs to be fetched from, or else from where the data needs to be put into. So both the things are being taken care by the registers. So the registers, you can interpret them as a kind of slate kind of thing. So whatever those are there in between, intermediately, the operands, the plus, the minus between the variables. Once again in the second statement, once again you are taking care of the result, whatever is occurred in the earlier statement. So all these things will be carried out by the registers themselves. And then the intermediate results, the addresses storing, and then fetching the addresses and putting the data inside. So all these things will be taken care by the simple high speed storage locations called as the registers. And then coming to the cache, this is nothing but a small amount of faster memory which is placed nearer to the CPU. So this is also once again a kind of temporary arrangement, wherein which, suppose if a program is having a similar kind of instructions wherein which it is referring to the same address or the same data very frequently, then the control should not be going from the CPU to the memory location. However, the recent past whatever that has already happened will be stored in the cache. So from that particular cache, it immediately picks up, or else it immediately accesses that thing, and then the needful will be done. So whenever there is a kind of instruction, first of all it looks into the cache whether the things are available in the cache or else frequently been accessed. Otherwise, once again it will be if not found, it will be like directed to the memory. So some sort of glossary items or else some sort of terminology you have to learn whenever you are learning about the CPU. So the first term you have to learn is the clock speed. So the clock speed is nothing but all the CPU's operations are driven by the clock signals. So these particular signals are measured in gigahertz. So you had seen some processor with 3.3 gigahertz. So it is nothing but they are specially mentioning the specification of the processor, that to the clock speed of the processor. The higher the clock speeds means more instructions are processes per second. So all these particular things will be like measured in the form of gigahertz. That too, all these things comes under the clock speed. Higher the clock speed means more instructions are processes per second. And the second item that you have to learn is the instruction cycle. So whenever you speak about the instruction, that is only one particular or else a particular statement in a program. So it comes out with FDE, that is fetch, decode and execute. So the CPU follows a kind of cycle known as FDE cycle, that is a fetch, decode, execute. Fetch in the sense that it retrieves an instruction from the memory and then it decodes, like what exactly is the instruction all about, or else what is the interpretation of that particular instruction. Depending upon that, the execution takes carried out. So that is the kind of a simple cycle called as the fetch, decode, execute instruction cycle. Then whenever you listen to the specifications of the computer, nowadays they are you may be hearing some sort of cores also, like dual core processor, quad core processors. What is dual, what is quad? So modern CPUs, earlier it was not the case. We were having only a kind of single core kind of processor, wherein which we used to listen only to the single core. However, in the modern specifications, they are mentioning about the cores also. So these particular CPU comes with multiple cores, just like dual core, multiple core, quad core or something like that. and allowing them to perform multiple simultaneous operations, improving the multitasking and parallel processing. Suppose if one instruction is not dependent on the second instruction, so parallelly both the instructions can be executed. So without wasting the time, one core will be handling the first instruction and the second core will be handling the second instruction. Parallelly both the instructions are being executed simultaneously, so that it will be like benefit, so that the user will be getting the benefit in the form of the time. So these kinds of cores, internally divided cores, are been helping out in order to do the multitasking kind of thing, or else the parallel processing kind of thing. So then comes the part called as the threading concept. So we are listening nowadays called as the hyper threading or simultaneous multi-threading, means SMT. So when we listen to the specifications, most of the things we listen is the cores and then whether it is having the SMT facility or not. So this particular SMT is nothing but it allows each core to run multiple threads. Suppose if there is one particular CPU with the dual core, so it is having two cores, and then each and every core, whether it is having the multiple threads handling capacity or not. So that particular threading capacity is called as the SMT capacity. It allows each core to run multiple threads, improving the efficiency in handling the multiple tasks. So there are few types of architectures, those are available, wherein which we'll be seeing it in the next session also very detailedly. However, in x86 and then ARM are the popular architectures. x86, whether it is Intel based or else AMD based. Intel is the processor company, and also AMD is also the processor company. So x86 architecture is meant for general purpose computing, and then ARM architecture, which is widely used in mobile phones or else tablets due to their power efficiency. So these particular two architectures or else two types are very much popular. If you take the case of a desktop, laptop, it follows the x86 architecture. If you take the case of the tab that we are using or the mobile phone that you are using, it comes with the ARM architecture. Then when it comes to the computer, the heat issues are obviously to be looked into. So there is a kind of heat management within the system. Either it may be having a kind of heat sinks, or else there are certain fans which controls the kind of heat that the computer generates during its operation. So CPU generates a significant amount of heat, and it requires cooling solutions. So heat sinks and fans are the solutions in order to cool down the computer. Coming to the other component, leaving over the CPU, the next component which takes the prominence is the main memory. So main memory, we can call it as the RAM, RAM, that is random access memory. So this particular it is a computer's primary storage, and where the CPU uses the stored data and the programs while they are being used. Here there are two things you have to learn. Suppose if you are writing the program, storing it in the hard disk or hard device, that is called as a program. But when you want to execute that particular program, it needs to be picked and put it into the RAM by the operating system. So that particular process is called, that particular program, whenever it is being lifted and put for execution, that is called as the process. So program in execution is process, and program which is just written and is stored in the hard disk is called just a program. So when you want to execute the program, it has to be situated in the main memory. Until and unless it is located in the main memory, the CPU can't execute the instructions straight away from the hard disk. So this is the computer's short-term memory where data is stored temporarily while programs are running. Suppose if you are running a Word application, so Word application needs to be staying in the, or else located into the RAM, or else shifted into the RAM. After the whole processing, word processing is over, whenever you are quitting out from the application, so the complete content, if at all you haven't saved, you have to save, and then if at all you had completed the word processing job, if you are quitting out, then the short-term memory will be wiped off after the exit takes place. So RAM is volatile. It is not non-volatile. It is volatile. So it loses its contents when the power is turned off, allowing the computer to perform tasks very much efficiently. The more RAM a computer has, the more data and the applications it can handle simultaneously. So in the next session, we will see the rest of the components that we wish to talk, like the registers cache we had seen, and then we have to see the input and output devices. So in the next session, let us continue with the input devices, output devices, and the operating systems in session 3. With this, I conclude this particular session. Thanks for your patience.